Okay, so 2.5 derivatives of composite functions. So today we are going to look at the chain rule. So let's say you have f of x, and that f of x is equal to g of x to the power of n. So how do we take the derivative of that? Okay, so we take the exponent, drop it to the front as a coefficient. We keep g of x and decrease the exponent by 1. Then we multiply this by the derivative of inside, derivative of g of x. If you had only, if this g of x was only x, right? Let's say you have x to the power of 4, then you take the derivative of it as 4, you keep the base x, decrease the exponent by 1, right? And you would stop there. Well, actually, if you took the derivative of x, which is the inside function, that would be 1, right? So therefore, the derivative of x to the power of 4 is just 4x cubed. But instead of x, if you have another function, okay, something like this, then you multiply this by the derivative of inside. So let's apply, and it will make more sense. So h prime, we take the exponent, drop it to the front, we keep this bracket as it is, decrease the exponent by 1, so 2 minus 1 gives you 1, and we multiply this by the derivative of inside, so 15x squared plus 8x. Now you see that x is a common factor here in the second bracket, so 2x, 5x cubed plus 4x squared minus 3, 15x plus 8. Again, everything must be in factored form at the end. So let's look at example 2, which is more complicated. We have h of x equals x cubed minus 1 over x plus 2 to the power of 3. Okay, h prime, take the exponent, drop it to the front as a coefficient. Keep the bracket as it is. Decrease the exponent by 1. So 3 minus 1 gives you 2. Now take the derivative of inside. So inside is a rational function. So you have to use the quotient rule to take the derivative of inside. So with 2.4, we learned how to use the quotient rule. So derivative of numerator, 3x squared, times the denominator, x plus 2, minus derivative of numerator, which is 1, derivative of x is 1, derivative of 2 is 0, times the numerator, x cubed minus 1, over square of the denominator. Now we will have to simplify this side. 3. So as I do that, I'm going to also distribute that exponent to the numerator and denominator, because I will need to put together these two denominators. Okay. So this gives me x cubed minus 1 square over x plus 2 square. Now expand these. 3x cubed plus 6x squared minus x cubed plus 1. Three x cubed minus 1 square. Now for denominator, we have x plus 2 square here and x plus 2 square there. So if we multiply them, we add the exponents. 2 plus 2 gives you x plus 2 to the power of 4. Now, collect these. So 2x cubed plus 6x squared plus 1. X cubed minus 1, that is also factorable. Difference of cubes. So let me put it here. Okay, so 3 x cubed minus 1. Factor it. X minus 1 using difference of cubes. X squared plus x plus 1. But it is squared, therefore these two are also squared. And we still have 2x cubed plus 6x squared plus 1 over x plus 2 to the power of 4. That's what I want you to now see something, pay attention to something. As you take the derivative, if you have a rational function, as you take the derivative, the exponent of or power of the denominator will increase by 1. If you look at the original question, it is x cubed minus 1 cube over x plus 2 cube. So denominator is x plus 2 cube. So when you take the derivative, now you have x plus 2 to the power of 4. So again, the power increases by 1. So that's how you can check your work at the end, if you did the derivative correct or not. So we can also go back and see with the 2.4. Let's say we had example 1. So origin was x squared plus 3. So when you take the derivative, now you have x squared plus 3 square. Okay. So that increases by 1. Or if you look at this question, so original has x cubed. And when you take the derivative, you get x to the power of 4. Again, it increases by 1. Next question. So we are taking the derivative, and f of x is given for x squared minus 7 squared times 3 plus 4x, square root of 3 plus 4x. Okay. So again, you can think this square root, write it with a rational exponent. 3 plus 4x to the power of 1 over 2. And then now we will have to apply the composite rule or chain rule here when we take the derivative. Okay. So now we apply product rule and chain rule together. So that is your first function, and that's your second function. When you take the derivative, let's remember the product rule here. If you have f equals h times g, f prime is h prime times g plus g prime times h. Okay, so in this case, your h is this and your g is that. So derivative of h, that's what we need, right? Derivative of h. So we are taking the derivative of 4x squared minus 7 squared. So since this has a square here, you will have to apply the chain rule. So that gives you, so drop the exponent in front, keep the bracket as it is, decrease the exponent by 1. So 2 minus 1 gives you 1. Times derivative of inside, which is 8x. So now this is h prime. So now we multiply it by g, which is 3 plus 4x to the power of 1 over 2. That is your g, plus g prime. We are going to take the derivative of 3 plus 4x to the power of 1 over 2. Again, we will have to apply the chain rule because this has a power of power. Okay, so 1 over 2, we drop the exponent in front, keep the bracket as it is. 3 plus 4x, decrease the exponent by 1. 1 over 2 minus 1 gives you negative 1 over 2 times derivative of inside. So derivative of 3 is 0, derivative of 4x is 4. So that is now g prime, and we're going to multiply it by h. 4x squared minus 7 squared. Now we are going to simplify this. Okay, so before I start factoring it, I'm going to collect 2 and 8x here and 1 over 2 and 4 there. Okay, so this gives us 16x, 4x squared minus 7, 3 plus 4x to the power of 1 over 2, plus 1 over 2 times 4 gives you 2, 3 plus 4x to the power of negative 1 over 2 times 4x squared minus 7 squared. So I didn't factor it yet. Again, I just collected the numbers, put them together so that we can see what is the common factor. Okay, so now look at the numbers. So 16x, 2. So 2 is a common factor. 4x squared minus 7. 4x squared minus 7 squared. So remember before chapter 2, we did a pre-chapter 2 handout, which was, factoring. So when you're picking the common factor, you take the lowest exponent. So in this case, we are going to take 4x squared minus 7 to the power of 1. The other one is 3 plus 4x to the power of 1 over 2, and 3 plus 4x to the power of negative 1 over 2. The smallest exponent is negative 1 over 2. So we take that as a common factor. Now open a bracket. So take the first term divided by the common factor. 16x divided by 2 gives you 8x. 4x squared minus 7 divided by 4x squared minus 7, gone. 3 plus 4x to the power of 1 over 2 divided by 3 plus 4x to the power of negative 1 over 2. So you subtract the powers. 1 over 2 minus negative 1 over 2 gives you 1. 3 plus 4x to the power of 1. Plus, now we're going to take the second term divided by the common factor. 2 divided by 2, gone. 3 plus 4x to the power of negative 1 over 2 divided by 3 plus 4x to the power of negative 1 over 2, gone. 4x squared minus 7 squared divided by 4x squared minus 7 gives you 4x squared minus 7. Now let's simplify inside. At the same time, let's get rid of this negative exponent. So move it to the denominator. Remember, when you are simplifying, negative exponents are not allowed. So you need to get rid of it at the end. You can either use rational exponent or you can put it as square root. Okay. So now let's simplify this. (24x plus 32x squared plus 4x squared minus 7, 36x squared plus 24x minus 7. Okay. So 36x squared plus 24x minus 7. If you get something factorable there, you should continue factoring. Okay, next one. It says, determine the equation of the tangent and the normal at x equals negative 1. and h of x given. So to be able to get the equation of the tangent, we need the slope of the tangent. To get the slope of the tangent, we need to take the derivative of h function. So again, we see the product of two functions here. So we will use the product rule. Okay, so I see a negative sign. So that may cause some mistakes on the way. So I'm just going to take it out, open a big bracket, because that negative sign belongs to the whole thing. Okay, so if I do this, then, when I'm taking the derivative, I don't have to worry about it. Just keep it outside of the bracket. Now, this is your, let's say, f function, and this is your g function. Again, when you're taking the derivative, f prime times g plus g prime times h. And again, I keep the negative sign outside here. I'm not going to worry about it. So f prime, we are taking the derivative of 2x squared minus 1 cubed. Okay, so drop the exponent in front, 3. Keep the bracket as it is. Decrease the exponent by 1, 2. Times, using the chain rule again, you have to multiply this by the derivative of inside, which is 4x. So this whole thing is now f prime. We multiply this by g, x plus 2 to the power of 4. Plus g prime, so x plus 2 to the power of 4, we're going to take the derivative of that. So drop the exponent in front, 4. Keep the bracket as it is, x plus 2. Decrease the exponent by 1, 3. Take the derivative of inside. So derivative of x plus 2 is 1. So this is g prime. We multiply this by h. Sorry, yeah, that should be f. Sorry about that. Okay, so we multiply this by f. 2x squared minus 1 cube. That is your f. Of course, after that, we need to simplify this. Okay, so check for the common factors. So let's collect these again, the numbers first, before we factor. So 3 times 4x, 12x, 2x squared minus 1 squared, x plus 2 to the power of 4. And here we have 4, x plus 2 cube, 2x squared minus 1 cube. Negative. So let's now check for the common factors. So 12x, 4 is a common factor. 2x squared minus 1 squared, 2x squared minus 1 cube, 2x squared minus 1 squared. X plus 2 to the power of 4, x plus 2 to the power of 3, x plus 2 to the power of 3. Open a bracket. So take the first term divided by the common factor. 12x divided by 4 gives you 3. So 2x squared minus 1 squared, 2x squared minus 1 squared, they are gone. X plus 2 to the power of 4. Actually, there should be x there. Yeah. Okay, so so you get x plus 2 to the power of 1. Plus, so now take the second term divided by the common factor. So 4 divided by 4, gone. X plus 2 cubed divided by x plus 2 cubed, gone. 2x squared minus 1 cubed divided by 2x squared minus 1 square gives you 2x squared minus 1. So negative 4 2x squared minus 1 square x plus 2 cube. Now we're going to simplify this part. So 3x squared plus 6x plus 2x squared minus 1, 5x squared plus 6x minus 1. Five x squared plus 6x minus 1. If you get here anything more factorable, then you should keep factoring it. Okay. How did we get 3x? So we divide this first term by the common factor. 12x divided by 4 gives you 3x. This divided by that is gone. This divided by that gives x plus 2. Rational numbers, it is not only a number, but it is you can leave the square root if it has variables. Tanya. Okay, so that is the h prime. Now we want to find the tangent at x equals -1. Was it -1? Yes. So we substitute -1 here. -4, -1 squared is 1, 2, -1 is 1, 1 squared is 1, so you get 1 there. So -1 plus 2, 1, 1 cube is 1. So sub in here, 5 minus 6 minus 1. 7, -2, 8. We get 8. So this is the slope of the tangent. Okay. So we need to write the equation of the tangent. So y equals 8x plus b. So therefore we need the point of tangency. So x coordinate of that point is -1. So now we need to find the y coordinate of the point. So we need to use the original equation to sub in. Okay. So if you sub in -1 here, so -1 squared is 1 times 2, you get 1. 1 cube is 1. -1 plus 2, 1. 1 to the power of 4 is 1. So you get -1. The point is -1 and -1. Now sub in -1, -8 plus b. So you get b equals 7. So y equals 8x plus 7 is the equation of the tangent. So now we also need the equation of the normal. Let's remember the definition of the normal. The normal is a perpendicular line, right? So we are looking for a line that is perpendicular to the tangent. So if it is perpendicular, then the slope of it is going to be, so you do the negative reciprocal, -1/8. So y equals -1/8x plus b, and that normal and tangent passing through the same point of tangency, -1 and -1. -1, sub in here 1/8 plus b, move it over, so -9/8. So y equals -1/8 x minus 9/8 is the equation of the normal.